Many companies are turning to AI systems to make better decisions. The promise is straightforward: analyze more data, reduce bias, and find the optimal answer. But something interesting often happens when these systems run long enough. Instead of producing bold breakthroughs, they frequently guide organizations towards safe, predictable outcomes. Decisions become more consistent, but also more average. And over time, that can quietly influence how innovation happens. Consider recommendation systems on streaming platforms. These systems analyze huge amounts of data about what people watch and which titles keep them engaged. Their objective is simple: maximize viewing time. Over time, the algorithm learns which types of content perform reliably. The result is a steady stream of shows that resemble earlier successes. Stories follow familiar structures. Characters feel recognizable. Even visual styles converge around patterns the data suggests audiences already enjoy. The system is doing exactly what it was designed to do. It minimizes risk. The same dynamic appears in many other fields. In finance, algorithmic trading systems prioritize strategies with stable returns. In logistics, optimization models choose routes that reduce uncertainty. In hiring systems, automated screening tools often favor candidates who resemble past successful employees. In each case, the system optimizes measurable outcomes: consistency, efficiency, predictability. And those goals naturally pull decisions toward the statistical average. This tendency comes from how optimization works. Most AI systems learn from historical data. They search for patterns that produced reliable outcomes before. The safest prediction is often the one closest to the center of past observations. Unusual ideas, unconventional products, unexpected strategies appear less frequently in the data. As a result, they receive lower confidence scores. The system does not reject novelty intentionally, but it tends to favor what has already worked. Humans often behave differently. People sometimes pursue ideas precisely because they seem unusual. Entrepreneurs launch products that do not resemble existing ones. Scientists explore theories that challenge established assumptions. Artists experiment with unfamiliar styles. Many of these attempts fail, but some produce breakthroughs. Optimization systems are designed to reduce failure, and when failure decreases, experimentation can decrease with it. This does not mean AI systems eliminate innovation. In many fields, they actually accelerate discovery. In pharmaceutical research, AI models help identify promising molecular structures faster than traditional methods. In engineering, machine learning systems can explore design possibilities humans might overlook. These tools expand the search space, but the final decision about which paths to pursue still involves human judgment. The tension appears when optimization systems move from supporting decisions to shaping them. Consider product development inside a large company. An AI system analyzes customer data and predicts which features are most likely to succeed. Following those recommendations appears rational. The company reduces risk and increases the probability of near-term success. But those predictions rely on existing patterns. They work best when the future resembles the past. A radically different idea may not fit the model's expectations. Over time, decisions guided by optimization can narrow the range of ideas that receive attention. There is a reasonable counter-argument. Some researchers argue AI increases experimentation. Because models evaluate outcomes quickly, organizations can test many more ideas than before. Digital platforms often run thousands of small experiments simultaneously. And that argument contains truth. AI can make experimentation cheaper and faster, but it also influences which experiments seem worth attempting. When recommendations consistently favor low-risk options, organizations may gradually shift towards safer choices. This can produce subtle second-order effects. If many companies rely on similar optimization systems, their decisions may begin to converge. Pricing strategies become similar. Marketing campaigns resemble one another. Product designs follow comparable patterns. Competition continues, but the range of variation shrinks. Breakthroughs often come from outside the optimized system, from startups, from individuals willing to ignore model predictions, or from shifts the historical data could not anticipate. Optimization works best in stable environments. Innovation often appears when conditions change. As AI systems become embedded in decision-making, this balance will matter more. Optimization can produce impressive efficiency. It reduces mistakes and improves everyday operations. But if organizations rely entirely on algorithmic recommendations, they may gradually become less willing to explore uncertain paths. The challenge is not the technology itself, it is how the technology influences behavior. AI systems are powerful tools for finding reliable answers, but the most interesting opportunities are rarely the most predictable ones. They often appear at the edges of existing patterns, and those edges can be difficult for optimization systems to recognize, which means that even in an increasingly automated world, human curiosity and willingness to experiment may remain essential. Because progress rarely comes from choosing the safest option. Sometimes it comes from deliberately stepping outside the average.